Hi, everyone. Thank you for joining. My name is Jorge, co-founder and CEO of Bops, the commerce inventory intelligence platform helping consumer brands avoid stockouts and overstock. In other words, we're helping consumer brands avoid lost sales, markdowns, and inventory waste at the shelf. So today we're going to talk about one of the capabilities of Bops, which is on-shelf availability. You're going to hear me talk about interchangeably between capabilities and automated workflows, which we're going to refer towards on-shelf availability. At the beginning, we're going to give you a brief intro about Bops and what the platform does. And then second, we're going to talk more about on-shelf availability, its workflow, how the algorithms work. And then we're going to go into a demo, and then we'll be done very quickly. So let's just get started. As I mentioned, we're very focused on avoiding stockouts and overstock at the shelf. It's a big problem. And part of the time that we have spent thinking about this problem is how do we bring suppliers and retailers together? Part of the insight into the market is that inventory flow is not synchronized with consumer demand. And I'm pretty sure you guys are familiar as suppliers with the famous bullwhip effect. Demand variability that happens at the retail store impacts directly on how the inventory or the flow of inventory goes into your retail DC or your manufacturing facilities. And then we have a very important concept called CPFR teams, which are what we call the link between you as a supplier and your replenishment teams from a retailer perspective. So we're very focused on kind of synchronizing consumer demand with inventory flow, taking into account what is happening in the market and what is happening in reality. Things like, well, is there a change in the weather pattern? Is this going to be impacting my product? Yes or no? Is there a promotion? Are we going to be using retail media to promote my product? What's going to be the impacts on the sales lift that we're having at the store? Is there a specific economic condition that is going to be impacting it? So that's really one of the reasons why we started Bops, and where we saw, well, if we really want to solve stockouts and overstock, we really need to bring suppliers closer into your retailer partners. And that's when we came in with the concept that you're going to see us interchangeably also use during the conversation and the platform, which we're anchoring most of our processes and workflows with CPFR or the CPFR framework. CPFR stands for Collaborative Planning, Forecasting, and Replenishment, which was started in the early 90s, yet it couldn't scale fully because technology wasn't in there. So we have built, based on some of those principles for some of the consumer goods industry experts, we have anchored that and bring technology and data to be able to fulfill the needs or bring together suppliers and retailers to solve the stockout and overstock problem. So let me give you a quick intro about what is the solution and what Bops does, and then we will get into kind of on-shelf availability. So from a platform standpoint, we're enabling CPFR 2.0 using the concept of collaborative inventory intelligence. So as you see, we're trying to bring consumer demand closer to inventory flow. And there's two major sources of data that we're using on a day-to-day, connecting the major suppliers of Walmart, of Target, of Kroger, and many other kind of distributors of the consumer goods industries. So we bring, obviously, the retailer data that today you have access through the different portals like Walmart Illuminate or Retail Link, Target, Kroger, and a few other kind of retailer connectors that you have. So we blend that data and bring it together, and then we blend it with your supply data. Again, most likely you have an ERP system like SAP, Oracle, NetSuite. So we bring the ERP data, and in some cases, your planning platform data like Kinaxis, O9, SAP IBP, and synchronize it with what is happening at your retail locations. Everything is store SKU based, and then we're able to pretty much match store SKU base with your DC SKU base and synchronize what is happening with consumer demand and inventory flow. Obviously, this is not that simple. There's two components if you see the top of the circle, which is merchants and replenishment. From a retailer side, the inputs of merchants and replenishment teams are key. Order frequencies, what is going to be my plans, how I'm going to be buying the particular product specifically towards each department and category. And then on the other side, for you as a supplier, you got the sales and CPFR teams. And in some cases, the marketing teams as well that are doing advertising, doing a lot of the sales lift, or even making a lot of shift in the consumer demand. So those inputs into the model are also key to be able to really give a good mechanism or recommendation or data-driven recommendations to the CPFR teams or supply chain teams or replenishment teams and sales teams of how much product do I need to have on the shelf at the right place, at the right quantity, at the right. Below there, you could see everything we call market data. From the supplier side or supply side, there's suppliers that are using third-party logistics, 4PLs like RJW. So bringing together that logistical data within, for example, your Walmart network, where you're storing your product at RJW warehouse and then they're consolidating and sending those products into a Walmart warehouse or stores, it's imperative to bring that inventory flow closer to consumer demand. Same with the market data. I think we mentioned it earlier. You got Nielsen, you got places like weather data, where if you bring all of that data together, then you start to get some very good recommendations for the sales and CPFRs of the consumer goods companies to be closer and work closer together with the merchants and replenishment teams. So if you look at the middle of the circle, which is where I should have started, the platform works by bringing or blending this data together, converting them into simple KPIs. We're very focused into simplicity. Simple KPIs, again, you're going to hear us say days of inventory, sales through, different inventory states like stockouts, potential stockouts, overstocks, particular balance inventories that are going to become overstocks, in-stock percentages, replenishment in-stock percentages. There's so many KPIs that I'm very happy today to share, but today the focus is going to be on-shelf availability. Then, towards the bottom, you have configurable algorithms. In the scope of today's call, we're going to talk about how do we configure an on-shelf availability algorithm that gives me, as a supplier, the signal to be able to act in store with my field services operations teams. Again, it could be a preferred service provider like a Costa or Anderson, or it could be some of you doing direct store audits in some of the major retailers. It really depends on the retailer. I know through Walmart where you guys have to go or do it through the preferred service providers. And then you're going to hear me talk about capabilities and intelligent workflows. How do the data feeds the KPIs, the on-shelf availability configurable algorithms into intelligent workflows. So let's talk about the workflows. And again, we're going to really focus on-shelf availability today, but giving you an overview of the platform, our collaborative inventory workflows are very focused on helping you reduce lost sales, markdowns, and waste. There's 4 major components, or what I call automated workflows, where we focus on. On the retailer side, obviously, we have retail planning. We're working with some of the major retailers, regional retailers, to help them with retail data sharing portals. Not everybody have a Walmart Luminate or a Target portal. So ideally, part of why we exist or is trying to bring collaborative inventory intelligence into the market is by the retailers being able to share that data for you as a supplier to be able to act upon. And on one end, you need to be able to act upon on ensuring you got the right supply. But as you're supplying, you also need to be able to know what is happening at the store to be able to adjust very quickly. Because reality is, and as you guys know better than anybody, there's never going to be 100% forecast accuracy. So we do have the different capabilities and automated workflows for retail planning. But if we stay on the left-hand side, we also have the retail execution. And here's where the on-shelf availability algorithms are. How do we send an on-shelf availability alert where, for example, I have a product that have been trending or selling 8 units a week, and all of a sudden it drops to 0, I still have inventory. Whoa, I want to make sure that I have some merchandisers to go and visit that store to know what is happening. And if you start to merge that with the newest technologies of RFID or shelf scanning robots, then whoa, I think then eventually you could have better planning, you could have better accuracy, inventory accuracy, and eventually you're going to start reducing lost sales, markdowns, and inventory waste. We do have the capability to give exception-based actions. We're not going to focus too much into that one. But if you right now go into the right-hand side, we do have the planning horizon or the supply planning horizon, which is tied more to inventory coverage, like smart forecast adjustments, inventory and supply chain planning coverage. So think about bops utilizing the data out of your brand manufacturing facilities or your brand DCs and being able to tie that in with the flow that you're receiving from your retail stores and retail DCs. So that's where we start to merge that from a future landscape. If you go down to the CPFR and customer service, we do have the typical inventory exceptions where you're going to be having a potential stock out, overstock, smart order management. If you have a certain inventory policy that you want to maintain in specific regions because you're promoting more in specific regions than others, then that's where you could also use the mechanisms of order management in platforms like Nova to be able to ensure that you're maintaining the right inventory levels. And then obviously the typical retail analytics and intelligence performance scorecards where you manage your OTIF, where you manage your sales velocity, your forecast accuracy, and a few of the other kind of KPIs that I mentioned. So let's actually go into subject today, on-shelf availability and how those algorithms work. So if you remember, you got the data. Most of the data today, it's mostly coming from Walmart Limited. In the past, Walmart Retail Link, which, as you guys know, we're going to be migrating to Luminate. You got the Kroger, the Target, and just name the major retailers that today are providing you with inventory and sales data to be able to process it and be able to create store SKU or location SKU algorithms that will be then sent into the right field services operators or field operators to be able to make adjustment to inventory if they need to, or be able to move the product and put it at the right shelf location. So let's just start with the process. If we start at the top and we're going to go clockwise, retail data processing, as I mentioned, is really utilizing the data at the store level and utilizing patterns. Give me 1 second. Utilizing different type of sales patterns and inventory patterns together, along with some market data to be able to spark those alerts. Okay, good. So we're getting something that is sparking some alerts. What is that? What is that meaning? What is the meaning of that? So if you go to the second kind of closed loop workflow, we're going to show you today that you have the capability of configuring some of those algorithms to drive those kind of on-shelf availability alerts. Again, what I talked about are the different on-shelf availability alerts. Let me just quickly go into the configuration. Bops has the capability of you, in a very simple Excel or our platform, which we're going to show you in a second, be able to configure your inventory policy. You configure your inventory policy because you don't only want to go backward and assess what happened. Why do I lose this? I lost this sales, or why do I'm having so many markdowns of inventory at Walmart or at Target? You want to be able to go forward. You want to be able to know what's the inventory state of my store item, of a particular store item, and what are the actions that I need to make, that I need to go take to be able to address a potential lost sales that is attributed to on-shelf availability challenges or phantom inventory challenges, or ensure that I'm not getting orders for some of the important overstocks that I have for a particular store item location, or the other way around, ensuring I'm not getting over forecasted for important overstock. And if you think about the other way around, ensuring that you're not being under forecasted or you're not being under order from those specific inventory state alerts. So CPFR comes trying to prevent you from having important overstocks and potential stockouts and stockouts. But once you have the inventory in there at the shelf, how do you then promote data-driven execution to be able to kind of ensure that your field operators at the shelf are making the right decisions? So you're going to see the capability. We're going to show you how do you configure your policy to take an inventory state of your store item, and it's going to make very much sense. And one store item could be in any of the states that you're going to be seeing in here. You could configure your policy to be tied to the Walmart max shelf life policy, or you could configure your policy as well to create your own algorithms. You could do your own demand prediction algorithms and then tie it back to your reorder point policy and challenge some of your retailers to ensure that they're managing your inventory or they're having the right inventory at the right place, and in this case, in your shelf. So if I go back into the process, we're talking about configuring the policy and the algorithms. So what does configuring the algorithms mean? So today, with most of our customers, and most of our customers are here in the US and in Mexico as well, we have a two-step approach that we could take. So I'm going to start with the left-hand side, which is the no sales algorithm. Yeah, the no sales algorithm, and I'm going to try to simplify it for everyone kind of seeing this presentation. The no sales algorithm, if you could see on the purple side, it's the trending of I've been selling somewhere around 5 units a week or 5 units a day in this case for a particular very fast velocity, high velocity item. So things have been looking good in the past, as you could see kind of as I'm scrolling in. And all of a sudden, it drops to zero, boom. But what is interesting is that if you look at inventory in blue, I still have inventory. So why am I having that behavior? And eventually, depending on the type of item, you could start to configure your alert depending on the days since last sales. In this case, let's just say this is a baking goods ingredient, for example, for some of our customers, which usually they're having, again, low velocity. So if we spend 12 days without a sale, then we're sparking an alert and sending that to the preferred service provider, Acosta or Anderson, for them to be able to kind of see or check what is happening at the shelf, which we're going to talk about it in a second. So that's the no sales kind of algorithm, which it narrows down the potential for inventory adjustments and phantom inventory. Now, if we look at the second approach, which is a more general and high level approach, is what we call the sales prediction or demand prediction approach, which is for slow sales. This has an 80 to 96% accuracy, depending obviously on the type of items and the type of category that you're on. But I'm going to spend a little bit of time explaining. So if you look at the same sales in purple, you can really see that you've been trending up and down between 5 and 10 for a particular item. And now I added something called the daily forecast. With Bops, you have the capability, obviously by utilizing the different sources of data that I mentioned before. So cleansing your retail sales data along with your inventory data, and then starting to run some machine learning demand prediction algorithms, you could really see, well, I should be selling 2 units this day. I should be selling 3 units this day because of X, Y, and Z. So that's the orange line that you're seeing here on the screen. What's interesting about it is that you could see kind of the forecast. Well, we've been having some very good forecast accuracy. By the way, you could also configure that this is, for example, the Walmart forecast. And you could just get the weekly forecast from Walmart and then obviously make the right divisions to see it daily and then see the patterns. It really depends on your need, your item, and where you stand on kind of the category and department. So I'm just trying to explain it generally. What you can see in this trend is that this item, right, was selling somewhere around 7, 8 items a day. And all of a sudden, it starts to sell 2, 3, 1. It really kind of is what we call the slow sales behavior. We still don't have no sales. We don't have days since last sales in this case, but we've been consistently below the daily forecast. And we still have inventory. So what is happening in there? That's where we sometimes raise the alerts to kind of some of the on-field operators to go check that out. This could be a supply chain issue. We do have, again, and I'm not the right person from the team to be able to speak about the algorithms, but we do have a bell curve where usually 5 to 10% of the slow sales compared to kind of the demand predicted algorithm, we're able to kind of see or predict with very high levels of accuracy if this is a supply chain issue or if this needs to go and be attributed to an on-shelf availability issue. These are the 2 approaches today we take with many of our suppliers, depending obviously on the supplier by itself. So I wanted to take the time to explain it to you because right now we're going to go into the platform and kind of show you some real life examples of how do these items behave at the shelf. So before we go in there, and I'm going to go back to kind of our process flow here. So we process the data. We run and configure the algorithms depending on the item and obviously depending on kind of your item and you as a supplier and your network. And then once you start to create or have these actions, we call them actions that the field operators need to go execute upon. Then we send them in a headless way. When I mean headless way, it could be through WhatsApp, it could be through Microsoft Teams, it could be through an API to some of the preferred service providers platforms. It could be to some other platforms like Field Agents, which are very good at doing store audits, and a few others. So we have that capability, again, in a headless way to send those alerts. As you're going to see today, we do have a platform by itself as well, where you can monitor and analyze those exceptions and even go and look and track at the history of that item to ensure that the alerts are sparking or the alerts are making sense to a field service operators. Once you configure that workflow, and I know I'm spending a little bit of time explaining the workflow, this could be all automated, by the way, then the field service operators is where they go into the store, and then they say, well, I got 6 items at this particular store in Bentonville that I need to go check. And that's where we really capture, and this is one of the key mechanisms that we're building with a few of the preferred service providers and a few other platforms, which is how do we get the root cause? How do we get a closed loop root cause analysis that we could use from the field operator to improve the retail data processing and the algorithm so that when we go back to the store, we have high levels of accuracy that there's on-shelf availability problems. Some of the typical root causes or the most common root causes that we do see is phantom inventory, where in this case, the store manager needs to do some sort of inventory adjustment. So the inventory adjustment to adjust the inventory at that store. This is key because it goes back to, if you go back to the mission of BOPS, which is commerce inventory intelligence, it goes back. If you have phantom inventory, there's no planning that is going to be able to help you. And like a few of our friends always mention, on-shelf availability and inventory accuracy, it's key to be able to have the right planning, the demand forecasting, planning and replenishment. Distribution board. This is another cost that we're seeing. Well, the tag is incorrectly placed at the item. We got plugged items as well. And there might be others as well, which we usually try to kind of incorporate as part of kind of the activities. So this is really kind of the closed loop feedback where we use data and algorithms to do on-shelf availability. And this just is a workflow that gets to improve or improves over time. One of the key aspects that I do wanted to mention, and I think I mentioned it earlier in the conversation today, is that there's other technologies like RFID or shelf scanning robots that I do think if they could work in the combination of this API algorithmic kind of alerts or actions that we're sending could definitely make on-shelf availability better for each supplier here in the ecosystem. So I just wanted to mention that because I think it's key. Today, we're very focused on kind of the data-driven on-shelf availability algorithms, but I just wanted to kind of mention that there's other mechanisms. But if you could use them in conjunction, depending on the type of items, I think it could be extremely powerful for you to make sure, for you to be able to avoid lost sales, markdowns, and returns. So if we go back, I want to get back to the platform, and I think we already talked about it. So I'm going to talk before we go into the platform by itself and the product demo for today, which is going to be very focused on-shelf availability, is a success story. I mentioned I wanted to bring one of a baking ingredients supplier of ours that has been able to kind of reduce out of stock or what we call lost sales by a significant amount. And the problem that they were having, and the reason why the algorithmic approach for on-shelf availability was because there was a lack of inventory visibility so that they could accurately replenish demand at the retail locations. So we started with the CPFR concept, and we quickly realized that the on-shelf availability alerts were very high, and we couldn't improve the potential stockouts or replenishment exceptions if we didn't fix the on-shelf availability. So we went ahead and worked with some of their merchandisers so that we could feed them with alerts so that they could go into the stores and then fix and provide us with root causes to fix kind of the on-shelf availability challenges that we were seeing at the shelf. So just wanted to kind of explain that story so that we could quickly go into the demo and share a little bit about ops here. As I mentioned today, the demo is going to be very focused on-shelf availability, but you could very quickly see the platform. We have a platform, but see BOPS, if you go back to the circle, as the engine. We could send all of these alerts and exceptions into any of the platforms that you as a supplier use, Power BI, Excel, Microsoft Teams, and other. The platform by itself has something extremely important, which is the configuration. I promised that I was going to show you some of the configuration. So let me just quickly come here into configured. Bops has the capability to configure, again, what's the inventory state of a particular location SKU or store item. Something that I'm going to show you today is what is an example of that configuration of a location product master, and how do we use that particular Excel configuration to give inputs, give a CPFR or a merchandiser or replenishment team inputs into the model and algorithm. So if you come in here, it is all, as I mentioned, headless. This could be combined with your Excel. I just want to show you just one example of what do we mean with configuration. So obviously you have your item code. You could do it by item, or you could do it by item and location code. In this case, is a store number. So you could see the same item for different type of stores. And Bops have the capability to really plan your network for a particular item store or a particular item DC. What is my lead time? What is my lead time from the time that a Walmart or a Target places an order until we receive it at the store or at the warehouse, depending on the model that you have set up or the inventory model that you have set up with your retail partner. What is the order frequency? So if I give you an example in here, are you requesting this baking goods, or are you requesting this cosmetic item 2 times a week, 2 times one time a week? Are you requesting this 1 time a month? So in this case, it's just twice a week. So we have it in week orders. What are the order days? You can see here that on Tuesdays and Thursdays, this is where I'm getting my orders, which is extremely key of how do we create the exceptions that go in line with the on-shelf availability. What is a typical demand type that I want to use for this product? Do I want Bops to create a forecast, or do I want to use the Walmart forecast or the Target point of sales? How I'm going to be creating that forecast? There's other configuration files that you could use to drive those. Again, it could be at the item store level, or it could be at the item level, depending on how you want to manage your business. I'm just giving you the capabilities of the product. Obviously, some of the things that we do see imperative is how a CPFR replenishment team member from a supplier standpoint, in conjunction with your retailer counterpart, in this case will be the replenishment team, could feed you with comments. I want to be investing in this particular product, so I'm going to be investing in ads. So these are comments that eventually feed the algorithms. I want to make sure that from my supply side, as soon as Walmart or Target is providing me, it's submitting a purchase order, I want to make sure that I have very high level fill rates. And if we talked about some of the Walmart metrics and some other retailer metrics, the on time in full is key in this particular area. This is a way for you to add kind of those inputs that goes back into the platform. So configuration. So once you run the configuration, you also let the data run. If you remember back, go back to the circle, you got the KPIs running, you got the inputs, you could bring market data, which I'm not going to show you today. But now in this case, it's one of the major retailers in your supplier community. And this is some of the items that you have. So Bops have the capability to really give you everything related to CPFR. Today, right now, you're going to be seeing the opportunities card, which we're not going to spend too much time, but you could really quickly see at the present, what is the lost sales that I'm having, how many store item combinations are in a stockout situation, how many are in a potential stockout situation. But more importantly, what I want to show you from this scorecard or opportunity scorecard is, what percentage of store items out of all my store items that I do have in this retail network or multiple retail networks, in this case, it's just one retailer, I'm having on-shelf availability alerts. Interesting. 1.68%. So we're going to talk a little bit about that and how those have been trending up and down, depending on the field service operations or the retail execution activities that you're having. So Bops is able to kind of measure all of that in details for you and tie it back to potential lost sales or overstock, which we're not going to get into the details today. I want to show you kind of what an on-shelf availability alert and algorithm is with real data. Obviously, this is encrypted and secured for our customers, but I just wanted to show you how the no sales or the slow sales algorithms works here. So not going to go into sales velocity. Here you could very quickly see a picture of how Bob's takes a snapshot of present and future. What is the state of a store item today, which could be an important overstock, an overstock, store stock out, complete stock out, on-shelf availability, or potential stock out. And you could obviously kind of have all the different multi-aggregated filters to be able to see where is this happening and why, and where do we need to get started. All of this, I do want to be very candid, is already automated. This is just a platform for analysis. Most of this is sent either through APIs or reports to Microsoft Teams, Outlook, and email. The users have the ability to configure their own exceptions and report to be able to receive them where they operate today. And a lot of companies operate still in Excel, in Outlook, Microsoft Teams, and that's where we submit some of the alerts depending on kind of the user profile and persona. Not going to get into fill rates, forecast accuracy. I want to really quickly jump into on-shelf availability to be kind of in subject today. So let's focus on what is this screen telling me. So today, this screen today is telling me, whoa, I'm having 108. I'm having 108 store item combinations that might be having an on-shelf availability problem. Why I'm saying might be having is because this is the alert. This is not validated until either we do a store audit or a field service operators goes into the stores and validate. This is, again, where we could potentially in the future utilize applications like Bolt that is happening today at Walmart, or utilize on-shelf scanning robots in RFID to be able to mitigate what is happening in there. So quickly, you could see here, something interesting is happening in Houston. And I want to see what's happening in Houston because I have some number of alerts in this one. Just for the purpose of demo, you could see that in Houston, we have 6. But we, as the company, have been working with many suppliers that could have thousands of alerts. And it's how you slice and dice those by the different regions or stores that will make an impact. Here you could see the stores. Another way that you could slice and dice is by any of the aggregations that you want to add. I want to see it by state. I want to see it by item, or I want to see it by store item. So I just wanted to quickly show you a way that you could slice and dice the data, create the analysis to kind of pretty much follow what are those alerts that you're receiving. One of the things that we're also doing a lot is configuring how you send those alerts into the field operators. If there's a field operators that is running a particular region, then we just only send those particular analysis to that region. We don't have to send all the alerts because we're overwhelming people. So that tactical coordination is something extremely important that we do in the backend and the configuration of the platform to be able to serve our suppliers and then help our suppliers really get the right root cause analysis. So if I go down, I want to go back to where we were with the demo, right? We quickly saw that Houston had some significant stores that had some on-shelf availability alerts. So I want to show you really how the alerts look like. And in this case, you really look at what are the stores in Houston that are having some alerts. So I really want to show you the data. So I'm going to come down here and I want to show you the store item data and what is making Bob's in the backend say, well, this is an OSA alert. So depending on the configuration of this particular item, you're going to very quickly see that this particular customer decided that they wanted to have 14 days since last sales for the phantom inventory or phantom inventory alert, or the no sales on-shelf availability algorithm alert. So in this case, as you could see, and I'm going to open this big for them, out of these items, I have this one at the top that have 23 days since last sales. They've been selling somewhere around 4.5 units a week. So pretty good, I'll say. It's a good velocity for baking ingredients. Walmart is forecasting for the next 2 weeks, 9.3. So very tight base, very in line with how much are we selling. Walmart forecast average is somewhere around 21. That's the 4-week average. So we might be seeing a spike very soon. So those are the things that are telling us. Bob's is able to give you all the data to be able to spark the alert. But I think the most important thing that I wanted to show you is the behavior that you as a supplier, CPFR, replenishment analyst, sales analyst that is reviewing these on-shelf availability alerts could actually leverage to ensure that the platform is giving you the right alerts based on the configuration, and then obviously the algorithmic predictions that we're doing to be able to spark that alert. So let's look at that. You can see the demand forecast weekly. Again, this could be a retailer forecast, or it could be your own forecast based on the scanning or POS data of your retail. It really depends on how you want to configure it. We try to create the platform extremely modular and, as I mentioned, flexible, so that each supplier, depending on their supply chain networks, their requirements, could configure it so that they could create this alert and then obviously save money at the shelf. So let's look at the behavior. So in orange, we got the demand forecast. In purple, you could see kind of the inventory. So there's a lot of ups and downs happening. And this is our weekly buckets. I wanted to keep it simple for today. And then you could see in green, it's pretty much the demand or the sales, the POS scanning data that are being having. So you can see some of the sparks. You can see that in October 29, they have a spark of 124 units, which is very interesting. And you could see really the behavior in green versus kind of the inventory. Where the alerts comes in, and if you look at where we are, I think it's week 52, but we are in January 21st, which started on Saturday, the Walmart week in this case. You can see with that, since December 31st, almost 4 weeks, I think it was 20-something days since last sales, it all trended down to zero. And if you could look in purple, we've been having inventory since that day. We got 13, and it all came down to 12. So quickly, kind of the tool in this case, with a very simple algorithm that you could also run, it's telling, whoa, I definitely need to go check this out. There has to be something happening. Walmart in this case, or Bob's, is forecasting. I was having a very good trend happening somewhere around 60. I was selling somewhere around 60 a week. I was having some very good performance at that particular store item. What happened? So that's a particular use case example of an alert that a field service operator for that store in Houston will receive. Let's see if we could bring some others. What is interesting as well is that you could see the future. And when you want to see the future, it's key, because if this wasn't zero and it was 2, but it was significantly below the tolerances of the forecast, based on the 5 to 10% tolerance of the bell curve that I was showing you earlier, then eventually that will spark the alert as well. What is key in here is that it has to be configurable. If it's not configurable, then again, off-the-shelf solutions are not going to work for you. So I wanted to show you why this is so important. And it's so simple. And I wanted to put you a quick example in here in the headless BI platform, that if you know what, I don't really care about the days since last sales were 14. This could be configured in kind of the Excel page that I show you. I actually just want to run the algorithm very quickly with just 10 days without sales. So let me reset again. Let's just make sure that when I see Houston, and then we reset everything, so we have 165. We want to put, rather than 10 days, we want to put, just give me the alerts that have been 20 days without sales. Boom. And then you run it, and now I have 85 conditions or actions that I need to go work upon. And let me just utilize that and pick another example to show you the pattern of how it looks like. So let me pick one that has 26 days since last sales, 525 units a week. That's the pattern. Walmart is forecasting to sell 7 in the next 2 weeks. The reason why it's forecasting for the next 2 weeks, that's because it's in line with the lead time for that particular supplier and again, it's the lead time from order creation, Walmart order, purchase order creation, into receiving that at the store. So it's very important when you're kind of analyzing those as we go, of having the supply chain network information and the supply information from that supplier. Where is that particular product on my supply network? How long is it going to take me to get there? So let's just quickly look at that particular item. And again, this is just a list, or it's an example of a list that a field service operators will receive. Usually they just receive 4 to 5 columns with, this is my inventory on hand, this is my sales pattern, this is my predicted demand, and I've been not selling these items for the past 20 days or 21 days, and boom, and then they go execute. You just get a list for a particular store, and then you just go look at the bolt. In this case, for the Walmart context, they look at the bolt, they look at the aisles, the sections, they look at the particular item. If it's there, good. They send us a root cause analysis that it is there. Most likely it's not there. It could be a plugged item, it could be a void, or it could be a phantom inventory that needs to go get fixed. This gets fixed, and then all of a sudden now you're planning again, and then you're starting to realize sales. If it was a phantom inventory, which this particular case looks like a phantom inventory, you'll be realizing sales as you go. So let's see if this is a good example. I'm not liking this as a good example. Let's see if we can get another one. Boom. There you go. You have a very strange behavior in this one. So you're predicting in this case, weekly demand of somewhere around 5 units. You've been selling a very inconsistent trend for that particular item, 47 in one particular week. That was probably because of a promotion at that particular store. What is interesting is that the reason why this or the bops engine is creating an alert is because, again, you were trending somewhere on average sales of 14, 17 units a week. All of a sudden, you sparked to zero, spent three weeks since January 7, and then you've been having inventory. So this is another example of a no sales algorithm where it will spark an alert. And again, you could have different type of behaviors for each of the items. And the idea is that, again, you're not going to analyze all of them. The idea is that you feel confident of the configurable alert in this case, based either on no sales or based on the slow sales algorithms that I was showing you earlier, so that you could really get or optimize the field service operators or the preferred service providers operators' time and money that you're kind of investing to really have accurate on-shelf availability. Again, we're still trying to work with many suppliers to kind of bring other type of technologies, as I was mentioning earlier, but that's where the future is going, and I think this is a good place to get started. Again, I'm not here to fully show the full demo of bops CPFRs and other type of automated CPFR exceptions and workflows, but that was all I wanted to show you today, which I think it's more than enough from an on-shelf availability. So let's get back to the presentation. So if we go back to the workflow, if you're able to do that in a closed loop workflow, then you win. The more you start doing it and the more feedback you receive, the more automated it becomes. The less analysis, like the one that we were just doing today, is going to start happening. And then eventually you're going to have very high levels of on-shelf availability at each of the retail store location, and then you're going to be winning. You're going to be beating your competitors, and that's part of the benefits of what we're seeing by using the on-shelf availability workflow powered by bops. As we mentioned, we're winning with our customers. This is improving, and especially for this baking ingredient supplier that I was using the demo with, you're getting 94.5 inventory accuracy in retail locations. This, depending obviously on the type of product you have, if you're having a cosmetic companies, for example, you could reduce markdowns up to 7%. But if you're having other type of general merchandise items, you could really, or food and beverage items, perishable items, non-shelf stable, you could really reduce waste as well, which is an important piece of the equation of winning at retail. And then last but not least, you're definitely going to be improving the lost sales. There's the concept of recovered sales. As soon as you start to adjust the inventory, if it was a phantom inventory, replace the item with the right label, print the label and the right label, you could start to see, based either on the forecast or the POS sales, your consumption, you can start to see that come down, and that's sales that you're regenerating that you haven't had since the day since last sales that we were mentioning before. So there's a lot of power. There's a lot of opportunities. I think as everybody says, the devil is in the details, but I think there's a lot of power in the bops on-shelf availability, and it comes down to how do you configure it based on your item, your network, your supply chain network, and then how do you really start acting upon it? Again, We do have the capabilities to do root cause analysis and go backwards to say, well, this is because we had a supply problem, or this is because we didn't fill the item right, or this is because it was a store execution item, it was a phantom inventory, or there was a clogged item. We do have that capabilities, but I think one of the key messages that I want you to take out of this presentation is the root cause analysis and going back to the past to improve kind of the algorithms, if you're going to use it to improve the algorithms, but it needs to be present and future-based. You need to be able to get these actions to mitigate and correct them with the right feedback so that you could really have the right levels of on-shelf availability that you wanted to have at your retail locations. So that's the core. That's what I brought for you guys today. It's been more than a pleasure. Thank you very much for your time. And if you have any questions, please either reach out to Conversations in Retail or reach out directly to me, Risquez at bops.ai. And then you could also go into our webpage, bops.ai, if you want to see a personal, I wouldn't say a personal, but if you want to see a preferred and directed demo with your own data of how a Bops on-shelf availability workflow will look like, and start measuring kind of its accuracy. So it's been a pleasure. Thank you so much. And if you have any questions, definitely reach out.